right. So first, let's look at the goals of text mining. So first of all, of course, we know that text is everywhere, right? So text is the most common and expressive form of information. It is the most natural way of encoding human knowledge, right? So through the forms of books, research papers, right? So Wikipedias, that kind of things. And text as data is tremendous and exists everywhere in multiple different forms. So that makes text very important to study with. Then why do we need text mining? So we have basically two tasks. Task number one, text retrieval. So since there is a tremendous collection of text available either on the internet or in the library in a digital form, then if you want to search for relevant text data, then you present a query, and based on that query, you are supposed to get the most relevant text data. So that's called text retrieval. Now, how we can achieve that goal, right? So we need certain algorithms, and of course, we need to implement that the algorithm to retrieve what we really want to have. And the second task is to, we call it text mining, is to create knowledge from information. Okay, so okay, so information now. So this is how things go. So you have text data, but that text data could from our point of view, would be a raw data, right? So they have not been processed. So then we clean up the data, process the data to get what we really want. So then that becomes information. So information then is structured and cleaned data. Okay, then from that information, we want to create knowledge. Okay, so text retrieval is to obtain information, and text mining is to obtain knowledge from information. So basically, that's the goal of text mining. And of course, from knowledge, you gain wisdom, right? So you become smart. So, but that is not the goal of text mining. How do you make text mining is not going to make somebody smarter. It just create knowledge from information, and information is cleaned and structured text data. So when we say structure, it just means that it's in a certain format that we can process. So once again, text mining is focused on the middle part, from information to knowledge. Okay, so traditionally before text mining, we have two disciplines. One is called data mining. The other one is called natural language processing, or NLP. So text mining is built on top of these two disciplines. So that means that we have two views for text mining. So the first view is from data mining. Following the general goals of data mining, text mining is to discover and extract interesting patterns in text data, including latent topics, topical trends, outliers, and summaries, among other things. So basically, we just want to discover patterns from text data from data mining point of view. And from an NLP point of view, text mining is to convert text into some form of knowledge representation. Not knowledge itself, it's just knowledge representation, and make limited inferences based on the extracted knowledge. Okay, so you may say, oh, I haven't taken NLP, what do we do? So don't worry about it, because we're going to use existing software tools. So that's NLTK will provide to you. Okay, so that's the 2 points of view of text mining. Then text mining, the ultimate goal of text mining is to build text information system, TIS. Okay, so that consists of the following parts or components. One is information access. The other is knowledge acquisition. Sometimes we call it text analysis. And then text organization. So how these texts are organized. For information access, the examples of it is search engine. So the first example, the search engine. So in a search engine, a user pulls information by making queries to TIS to retrieve text files or text data that match well with the queries or text documents, right? The second example of information access is recommender system. So this TIS pushes information to a user, right? Actively makes recommendation to a user, right? So that's called recommender system. For knowledge acquisition, we have, for instance, analysis engine, which allows a user to pull opinions about a product and opinion comparisons about similar products. The second example is called DUI. So this is built by my research group. It allows a user to pull sentences according to their relative importance on the given document to facilitate reading, and pushes questions of various types to users for assessing reading comprehension. So that's what DUI does, and you can try it out yourself. So this is a web application, DUI.com, right? So DUI.com, then you can go there and try it out. And text organization is to store text data for easy access and knowledge discovery or knowledge acquisition. Excuse me. So that's what a TIS is about. Now let's look at a picture of a TIS architecture or components. Now, so this is a typical TIS. Of course, a specific TIS may not contain all the components in it, right? But we just list basically what text mining is responsible for doing. So these are some of the popular tasks for text mining system to do. So first you have a data set of your text documents. Okay, so you use natural language content analysis to process this data. So what that means would be you extract words, you compute the semantics of words, and you look at the parts of speech of each word in a sentence, right? So those are natural language content analysis. So once again, even though we don't assume that you have taken NLP, so don't be scared by this, because we can just simply use existing tools to perform these tasks. So this is the bottom parts of the TIS, and that's not part of text mining. And the text mining is here. Okay, so this is a information organization after you use NLP tools. And from this information, as we said, we're going to create knowledge using text mining methods. Okay, so these are the subtopics or the knowledge we're going to discover. So that includes summaries, filtering. So this is information filtering, search, classification, or also called categorization. So, excuse me. And visualization. So how do we visualize a text data? Clustering according to latent topics. So clustering and categorization are similar, but categorization has labels and clustering doesn't have a label. So which means that you would need supervised learning to get classification, and you don't need supervised learning to do clustering. And then extraction. So for instance, you have a document, I present a queries for certain content of the document, then you can extract that content out of it. So that's a query-based extraction from a document. And for search, it's a query-based, but it's search for documents, okay? So you have a corpus of documents, you present a query so that you will get documents that are most relevant to your queries. Okay, so there's query-based extraction from a document, and the query-based extraction of documents are different tasks. And the search engines are easier. And then we have topic analysis. Okay, so going to this direction, we create new knowledge. And for this part, okay, so this is sort of for retrieval application. So that's a overview of a text information system. So text mining is on this part. NLP is here. Okay. Okay, so now let's mention software toolkits. Excuse me. I don't know whether you have got your textbook yet, but the textbook is written based on a software toolkit called Meta Toolkit, as I said earlier. This toolkit was no longer supported, and I tried to install it on a current version of the C++ compiler, and there are certain issues because because it was not updated. So that's why I would say that you should not try to spend time to make this work. Instead, the easier way to do it is to install NLTK and learn Python. Okay, so this is so Meta Toolkit basically is a C++ based a package that provides functionalities of processing text, and NLTK does the same. Okay, so you install Python, the current version of a Python, and then you install NLTK, and that NLTK comes with a book. Okay, it's an online book, right? It's a free book. So you also download that book and follow that book, and to get yourself familiar with some of the functionalities of handling text. Okay, so that makes text processing a lot easier. And also Python is an easier language to learn. Okay, later on when we talk about something else, like search engines, we may also install pandas and some other things. But right now, try to install Python, try to learn Python on your own, and try to install NLTK. Okay, let's see. So next, we're going to look at text data understanding. So when you have a corpus of text documents, or you are given a single document, so the first thing you want to do is to get the words out of the documents, right? So that means that text mining is built on top of NLP, which is used to perform the following tasks, among other things. Okay, so I have these 5 bullets here. One is a lexical analysis. So this part is to figure out the basic meaningful units in the text data document. Of course, that usually means words. Sometimes it means phrases, right? So there's a basic meaningful units, such as a noun phrase or a verbal phrase, and then determine the meaning of each such unit, or then we call it word. Okay, so in English, if you just need to figure out words, that's easy because the words are separated by space and punctuations, right? But in some other languages, this task may not be so straightforward. For instance, in Chinese, you have to come up with a good tool to segment these basic units out. So that's called segmentation, but that belongs to lexical analysis component. So then, of course, we are not to build such tool because we just need to use existing tools to do this. Okay. Building such tool is not our job, right? So that's NLP. That's a job of NLP. And then the second NLP job is syntactic analysis. So this is to determine how words are related with each other. So this is sort of like a grammatical issue, right? So again, we're going to use existing tool, existing NLP tool to do it. And the third NLP task is semantic analysis. So this is to determine and infer the meaning of a sentence. So in order to do that, of course, you have to first infer the meaning of each word from lexical analysis. Okay, again, we have existing tools and we may need to build new tools because NLP by itself may not provide the things we need. Okay, so for instance, in Dewey project, we have to build our own tool to come up, to infer the meaning of a sentence. And the fourth task of NLP is pragmatic analysis. So this is to determine meaning in context, which is focused on the effects of text on meaning. For instance, when we see a sentence, we want to know what the speaker of speaking that sentence, what he really means, right? So this is a pragmatic analysis. So that's harder to do. And the fifth NLP task is called discourse analysis. So this is to determine the meaning in multiple sentences, focusing on relations of a sentence to other sentences. Okay, so pragmatic analysis, you may just have one sentence that we want to figure out when the person speaks that sentence, what he really means by that. And discourse analysis, you have multiple sentences and you want to know the relations of one sentence to the other in a set of sentences. So now, by now, I'm going to ask you to think about the following. Okay, what does it mean by understand something? And how can you tell if a computer understands what an article means? Now, this is really a fundamental question. There is no clear answer to this, but we should think about it from different perspectives. Okay. Okay, so now let's look at an example of what NLP tools can do for us for text mining purpose, right? So let's say I have a sentence, a dog is chasing a boy on the playground. So this is an English sentence, so the words, the basic units or lexical analysis is easier by separating these words to extract words by just looking at space and punctuation. Suppose you have a period, right? So this is one basic unit, another basic unit, right? And so each word, each English word in a sentence is a basic unit. So this is lexical analysis, and then we will determine the part of speech of each word. Okay, so this is a part of a speech tagging. Dog is a noun, chasing is a verb, but it's in the form of is chasing, so you have an auxiliary. A boy is a noun, on is a preposition, and playground is a noun, right? So this is called part of a speech tagging, or POS tag, POS tag. And then if we want to parse this sentence, then you want to get a grammatical rules, then that's called syntactic analysis, or called parsing, to make sure this sentence is grammatically correct by doing this parsing. So there's a parse, of course, you use grammatical rules to come up with a tree-like structure, right? So you start from a sentence here, and the sentence can be formed by a noun phrase and a verb phrase. And the verb phrase can be formed by a verb phrase and a preposition phrase. And the preposition phrase can be formed by a preposition and a noun phrase, and a noun phrase can be formed by a determinant and a noun, right? So that is called parsing. That's a syntactic analysis. Now, we can just use existing tools to do this, right? From NLP toolbox. Now, for the semantic analysis, it's basically, it tries to come up with a predicate. So let's use D1 to represent dog, B1 to represent boy, and P1 to represent playground. Then this sentence, from its meaning, is tracing. So this is a predicate. Okay, this is a verb. So we can think of a verb as a predicate. So this is a D1 dog, B1 a boy, P1 is a ground. Okay, so the whole sentence is now compressed into the following predicate. And then what is inference, right? The inference here is that you have an implicit rule, which means that if this predicate is true, if tracing something on X, something is true, then this X is scared. Now, this is implicit, it's not in the sentence itself. So this just sort of like a implicit rule for doing inference. So then you combine these two, then of course what you can infer here is that by looking at this sentence, you can infer that this boy is scared. Okay, so this is semantic analysis and inference. Now let's look at the programmatic analysis part of it. So this is a speech act, so which infers or which tells you what the speaker, when he says this sentence, what he really means. So here, what he really means is that somebody needs to take care of that dog, right? So a person saying this may be reminding another person to get the dog back, so that stop that tracing because this boy is scared. So that is programmatic analysis. Now, as you can see here, inference and programmatic analysis is, these two are much harder tasks for NLP. And existing tools can do lexical analysis, part of speech tagging, and parsing. Okay, so they can do parsing, and they can also carry out semantic analysis in the form that they figure out each fragment of a sentence. They are semantic rules. They can do that. They can do that one pretty well. But the inference part and the programmatic analysis part is hard. Is harder. Okay, so now after we look at some of the NLP tasks, now we're going to mention some of the challenges that NLP is facing. So that when we do text mining, then we need to find ways to take care of these challenges. First is a word level ambiguity. So you extract the word, right? But sometimes this word may have multiple syntactic categories, which could be, for instance, a single word could be a noun and could also be a verb. So this is, it belongs to more than one part of speech categories. For instance, design can be a noun and it can also be a verb. So that means that we have this ambiguous past tagging. For another example, sometimes a word has multiple senses. For instance, root is polysemous. It has more than one meaning, right? So it's polysemous even as a noun. Okay, so for instance, it could be part of the plan or it could be a source, right? So it's ambiguous sense. So how do we take care of this when we perform our text mining tasks? So that is one challenge. for NLP and also for text mining. So we should, when we develop text mining applications, we need to find ways to take care of this challenge. The second is called syntactic ambiguity. So in other words, sometimes, well, we know natural language is inherently ambiguous in the sense that it has multiple syntactic structures. So in other words, you don't have a unique parsing. So this is different from computer language. Computer language is deterministic, context-free grammar. So that means that so each sentence has only one syntactic structure so that you can build a compiler to interpret what that sentence means. However, for natural language, it's not doable. This is an example. So we have a sentence, he saw a boy with a telescope. So this is a perfectly correct, grammatically correct sentence, but it has two meanings because it has two distinct syntactic structures. One is that he saw a boy, so that boy has a telescope. So in other words, he saw a boy and that boy has a telescope. The other one, the other structure is that he saw a boy using a telescope. So of course, this has two different meanings, and this sentence is perfectly correct. So that is a NLP challenge. So it's ambiguous prepositional phrase attachment. So when building text mining tools or applications, we need to find ways to take care of this phenomenon. The third is anaphora resolution. So this has to do with a pronoun. So unclear reference of a pronoun. For instance, in the following sentence, John persuaded Bill to buy a car for himself. Okay, so now this is a perfectly good sentence, grammatically correct. However, for this himself, we don't know exactly what it refers to. It could be referred to John or could be referred to Bill in this sense. So this pronoun doesn't have a clear reference. So how do we take care of this in text mining applications? So of course, we don't have any clear solution at this point. Okay, such tools don't exist yet, but still we need to find ways to get around this or somehow to address these issues. The fourth challenge of NLP is presupposition. For instance, it's difficult to infer what it means by, for example, the following. He has quit smoking. So by looking at this sentence, we know that he smoked before. Otherwise, there is no need for him to quit smoking. So that means, so it implies that he smoked before. But then such things is hard to infer, even though it's easier for humans to understand something behind this. He was a smoker, so that's why he needs to quit smoking. So that goes back to my previous question to you. What does it mean by understand something? By looking at a sentence, what does it mean by understand that sentence? Does it mean that you can correctly parse that sentence, correctly figure out the meaning of it, or you can correctly figure out the inference of it, right? So this has different levels of understanding. Okay, so of course the ultimate goal to understand something is to understand its influence, understand its relations to other things. But that, again, is challenging. Nevertheless, we can still do a lot of meaningful text mining applications. For instance, at least 4 tasks that text mining can do. One is classification retrieval, classification/retrieval. So you classify a document, which categories this document belongs to, and then you have a query, and I want to find a good match of that query. Find to select a document from your corpus to match that query. So that can be done. And that's the easiest thing to do for text mining. And the second is summarization or extraction or topic mining. Okay, topic mining means topic modeling. So you have a document or you have a corpus of documents. And of course, these documents, obviously, they talk about certain things. They talk about topics. So now you want to find out what those topics are. And of course, you try to come up with, trying to figure out what sentences are more important than the others. And you can come up with summarization. And then the third, that's harder than this, is translation dialogue. Translation/dialogue understanding, right? So because dialogue engage of interaction, so you say something, the other person says something, then you say something, and he says something else, right? So that you figure out the meaning of those. And translation usually means a dialogue from one language to the other. And then the last one is the hardest one. The hardest text mining task is question answering. You you have a question, you want to answer that question to the point that the answer is correct to the question, right? So this is question answering generation. It could be engaged in a dialogue in a chat, or it could be used to assess people's understanding of certain things by asking questions. And you need to present an answers and then verify whether the answer is correct. But nevertheless, so these tasks can be done. But then, of course, the only problem is that how well we can do this. Okay, so there are quite a bit of research going on these topics. And Dewey, the system we mentioned earlier that was built by my team, is focusing on ranking sentences, which can be used for summarization, and also question answering. Okay, so next let's look at, excuse me, how we represent text. Okay, so of course so you have a text data, and that text data could be written in different formats, right? So you may have a TXT file, that's really text file. You may have a Word file, so with certain formatting effects on it, or you may have PDF file. So how do you get the text out of it? So which means that you want to convert these different formats of text documents into a pure text document. So that's the first job you need to do. Okay, and then once you have a pure text document, and how do you represent that document? There are several ways to do it. So the easiest way is to represent that document as a long string of characters, including punctuations, including space, right? So it's simply a string of characters. That's the easiest way, but of course, it does not provide useful information. So you simply look at a text file, a pure text file, as a string of characters. The next is you look at a text file as a sequence of words or word segmentation. So instead of just looking at a text file as a string of characters, I'm going to look at a text file as a sequence of words. So that's another way to represent a text file. So as I said earlier, it's easy for English document. It's not so easy for Chinese because you need a good segmentation tool to segment words in a document written in Chinese and some other similar languages. And the third representation of a text document is to represent a document as a sequence of past text. And you can represent a document as a semantic, using semantic structures and semantic role labeling. For instance, you can identify a sentence, divide them into, label them as subjects, verbs, objects, and so on. So that makes it easier to come up with a predicate, because usually verb is a predicate and the subject is the actor, and the object is something that receives that action. So there you have a predicate. And then you can also represent a text file into a graph, right? So entities, so these entities could be sentences or could be words or could be phrases. And then you look at the relations between words or between sentences or between phrases. And sometimes you can also organize your text file into a graph that represents time series or events that happens according to time, right? So these things are useful text representations. And then logic predicates, which can be obtained from semantic role labeling, and speech acts, so which is a pragmatic analysis that we mentioned, that you try to understand what this sentence, when a person speaks that sentence, what that person really means. So that's called speech acts. So these are different forms of text representation. We will use, for the most part, for text mining, we can use number 2, number 3, 4, 5. So these are easier to use. And number 6, 7, and 8 are harder to come by, but it should be a research topics that when we try to develop a text mining application. Okay, once again, let's look at an example. So this is the earlier example we have. A dog is chasing a boy on the playground. So for this, we are simply looking at this as a string of characters. A is a character, space is a character, D is a character, O is a character, and so on. Or we can look at it as a sequence of words. right? So a is a word, dog is a word, is a word, and so on. And then we can get a parse text for each word. And then we look at syntactic structures. So that is the parse tree. And then we look at entities in relations. A dog, that's an entity. So it's an animal. So the relation is trace a person, a boy, on the playground. So that indicates location. So this is entities and relations for the sentence. And if you have multiple sentences, then you can also look at relations between sentences. And then you come up with a logic predicates. Okay, so tracing is a verb. And then you have subject, you have an object, and you have location. So you put them into this predicate. And the speech act, as we said earlier, it really represents a request. One person asks another person to manage that dog, right? So that's a request. Stop tracing, right? Because that boy is scared, right? So that is an inference from this. Okay, so that's a different representations of a text. In this case, we use a sentence as a basic meaningful unit in a text document. And a sentence, of course, is built on top of words. Okay, so the next, we're going to look at the different text representation methods and look at its generality and the analysis it can do and examples of applications. So the first method is to represent a sentence or a text document as a string of characters. So then, of course, it can be applied to any text documents. It can also be applied to anything in digital form. It's simply a long sequence of symbols or characters. So then, of course, we can, if we just need to do string processing, such as a matching, right? You want to find, we want to do string matching. Then, of course, you can simply represent a text document as a string of characters. And this is a useful information for compression. You can you can convert it, a text document, into a binary form by looking at their encoding, and then you can figure out how to compress it, right? For instance, using Huffman trees, you can do information preserving compression. You can also do other kinds of compression, which may lose information. Excuse me. So that's at the string level. And then you can look at the word level representation. So it's still quite general because any natural language is built based on words. Okay, so then we can analyze. So this enable analysis includes word relation analysis, topic analysis, sentiment analysis. Example of application includes thesaurus, discovery, topic, and opinion related application. And syntactic structure, so this is a, you look at parsing. So enable analysis includes syntactic graph analysis. Applications include stylistic analysis. Okay, there are quite a bit of software tools to analyze your styles when you compose, and structure-based feature extraction. For instance, you have this Grammarly, right? So that's a software that if you watch things on YouTube, you always see this Grammarly advertisement. So that is really a syntactic structure analyzer. So that's a text mining tool. And then the next one is entities and relations. So enabled analysis includes knowledge graph analysis, information network analysis. Okay, so you represent sentences, relations of sentences, or also relations between words, and maybe relations between events, right? So this can all be done. So examples of applications include discovery of knowledge and opinions about specific entities. Okay, so once again, knowledge really means a processed information, right? So you process information, you obtain certain conclusion. So those conclusions will become part of a knowledge that you can learn. So, so that's called discovery of knowledge. And the last one is logic predicates. So the generality is small, right? So this is narrow. And enabled analysis includes, excuse me, integrative analysis of scattered knowledge and larger inference. Now, once again, this is kind of hard. We want to do any inference at this point. And IBM try to do this inference by building Watson. But as far as I know, that project Watson is not that successful. So that indicates it's a really difficult thing to do with tremendous power. And I think IBM spent $4 billion, more than $4 billion to build Watson. And examples of application include knowledge assistant for biologists or for doctors, right? So for us, we use word representation and static structure representation and semantic representation a lot. And so these are harder. But of course, we still, because we need to rely on NLP research. So some of the NLP research, their current status is not good enough to apply for text mining. Okay, excuse me. So that is basically what text mining is about and why it is built on top of NLP and what NLP tools are available for text mining applications. So next we're going to look at statistical language models. Because when we look at words, we need to figure out the probability of certain words appears in a document. So for doing that, we first need an overview of probability theory. And in particular, we want to find out how to estimate distribution parameters. Okay, so with that, we're going to start the next topic. So are there any questions at this time? Okay, now I have 5 minutes left. So instead of starting this new topic, maybe since now I have 8 participants now, let's do a brief introductions to ourselves. Okay, so that I know some of you already, but I don't know some others. So I would like you to, if you can, turn on your camera so that I can see you sort of in person, and each of you say a few words. For instance, your name and your background.
I can start.
I guess I'll go first.
Oh, okay, yeah.
So,
Okay.
hello guys. My name is Tahir Khalifa, and I'm a computer science major. I'm taking these special topics as in a CS electives or technical electives. This is my last semester in UMass Lowell. Hopefully, I'll be graduating in summer. I find it a really interesting class, so I just decided to take it. Hopefully, I'll get a really good grade so I can graduate it from here.
Okay, are you driving?
Unfortunately, no, I stopped.
Okay, yeah, it will be dangerous if you're driving.
No. Well, what happened that my grandma was in a hospital, so I just came home from it. So I've been listening to lectures from all the way down to Melrose.
I see. Okay. Yeah.
I stopped. I'm at home, just sitting in my car right now.
Okay.
Yeah.
Next.
Hi guys, I'm Brian. I'm a master's student in my second semester at the university. So I think this class sounds really exciting. I'm looking forward to a good semester with folks. And yeah, it should be great.
Yeah, Brian, I just want to catch up with you about your music work.
Sure, yeah.
Yeah, and maybe some other time, just want to catch up with you. You can also continuing on that topic if you want to. Yeah, and come up with a research paper.
Great.
Next.
Let me introduce myself. Yeah. Hello, everybody. My name is Yichen Sang. I'm a PhD student of Professor Wang, and my study area is text mining. So I can learn a lot from this class. I hope I can do much better text mining research on this area in the future after this class. Yeah. Thank you.
Okay, next. Any volunteer? Is somebody speaking?
Oh, okay. So my name is Gao Gao, and I am also a PhD student, and this is the third year. So I also in the Professor Wang's group. Yeah, that's it.
Next.
Hey everyone, my name is Chang Fengyu. I'm a PhD student, and I'm a student. I'm a student in Professor Wang's text mining group. I'm very interested in the NLP about the information in the text. So I take this class, and that's the first year of PhD student. That's it. Thank you.
Good. Next. Who's speaking? Oh. So time is up, so I guess we'll stop here. We can continue this introduction. next time. So once again, I have an office hours from 5 to 6 on Mondays and Wednesdays. Okay. All right, I'll see you next. I will see you on Wednesday.
See you Wednesday.
Yeah, bye-bye now.